Hello and welcome to another exciting chemistry session. This is your host, Mr. Mansur. So we continue looking at the writing of chemical formulas. So we're still in the series of writing chemical formulas. Now, as of today, we're going to look at chemical formulas that incorporate what we call radicals. Chemical formulas that incorporate what we call radicals. So radicals are just atoms that do not exist on their own, atoms that do not exist independently, but they exist as a group. And down below, we are looking at the names of radicals, the symbols, the charge, and the valency number. So we have radicals that are common. That are commonly used in formulas. So radicals such as hydroxide, nitrate, nitrite, ammonium, carbonate, sulfate, and phosphate. So these are the ones that are commonly used in the formulas, and we are going to look at examples that involve the same highlighted radicals. So our focus is on the name. It's a must to have to know the name of a radical. We have to know symbol. The charge at this particular point is optional, and valency number. These are the key three things that we need to know about the radicals. We have to know the name of the radical, we have to know the symbol of the radical, we have to know the valency number. So just to help you remember the radicals, because it is a must, you have to not really master, but you have to know. So I normally group them. So I group hydroxide, ammonium, so this is ammonium, NH4, that is ammonium, nitrate, NO3, NO3, nitrite, NO2, NO2. So these are grouped as one because their valence number is 1. So these are grouped as one because their valence number is 1. Then a carbonate, which is CO3, and a sulfate, which is SO4. The valence number is 2. And the last one with a valence number of a 3 is a phosphate, which is PO4. So allow me to make a very quick emphasis on the radicals. So whenever you are writing radicals, ensure that they are of the same height. The letters are of the same height. So radicals, we are very much particular when we are writing. Ensure that the letters are of the same height. If it's hydroxide, it's OH. So ensure that the letters are of the same height, and all the letters in a radical are capital letters. They are capital letters. You do not find a small letter in a radical. So all the letters that are used in a radical are capital letters. So it's N, O, 3. And then pay attention to the numbers. Pay attention to the numbers that are used in a radical. Those numbers that you're seeing as a subscript. So we have these numbers that you're seeing as a subscript. Those numbers are permanent. Those numbers are permanent. So carbonate is carbonate is CO3. The moment you just change this number, then you change the name of the radical. Nitrite is NO2. The moment you change this number, you change the name. As you can see, NO3 is nitrate. NO3 is nitrate. But the moment we just change from NO3, we go to NO2, the name changes to nitrite. So that is how important those proportions are. So make sure that you do not tamper with the number which is a subscript. So the number is always permanent. So it's PO, a subscript 4. I'm not writing PO with a full 4, no, but it's a subscript. So a number comes as a subscript, just down there. So this is how we can remember the radicals. You can group them in their respective valency numbers. So hydroxide, ammonium, nitrate, nitrite, they have a valence number of 1. Then carbonate, sulfate, a valence number of 2. Then phosphate, a valence number of 3. Now let's look at how to write the chemical formulas with involving radicals. What are the rules? So these are the steps that we need to follow. So you identify the elements or the radicals present in a given compound. So there are times when an element combines with a radical, and there are times when a radical combines with a radical. We'll look at the examples very soon. Write the atomic symbol. So we write the atomic symbol of either it's an atom, it's an element, it's a radical. State the valence number. So as usual, write the valence number on the top right side as the superscript. Interchange the valence numbers. Now there is a special comment here. There is a special comment that should be observed. So we're going to practice this comment. During the interchange of the valence numbers, a radical is enclosed in brackets if its subscript. So if a subscript is greater than 1, let me just give an example. So if this is A and this is B, and then B is a radical, B is a radical, B is a radical, then A is just an independent element. A is just an independent element. So what this comment means is that if you have a 2 and you have a 1, when you interchange, A gets 1, but a B, if a B is a radical and a number which is more than 1 is a it's a subscript, the B should be put in brackets and then the 2 is put there. Remember, a radical is a combination of elements. So OH, for example, hydroxide. So there are 2 elements involved. There is oxygen and there is hydrogen. So if a number which is greater than 1 is going to be a subscript for this, so you have to make sure that you put it in brackets and then you put a 2 to show that that number is affecting both oxygen and hydrogen. But if it's an element, where I say A2, there is no problem. There is no need for me to put the A in brackets because this is just a single element. But for a radical, we always put a radical in brackets. So we'll look at some examples to elaborate this comment. So we can look at the examples. So we have lithium hydroxide. Lithium hydroxide. So when we look at lithium hydroxide, in lithium hydroxide, we have lithium and we have hydroxide as a radical. So lithium is an element, it's just Li, but hydroxide, remember, to be consistent with the capital letters, that is hydroxide. What are the valence numbers? So the valence number of lithium is 1. The valence number of hydroxide, according to the table of radicals, is also 1. Then according to the rules, when we have equivalence numbers, we just cancel them. We cancel them out and we have lithium hydroxide like that. So that is lithium hydroxide. That is where this formula is coming from. Let's look at barium nitrate. So barium nitrate, you have barium, which is capital B small a. What is a nitrate? So a nitrate is NO3. NO3. The valence number of barium. So barium is an element. You find the valence number on the periodic table. The valence number is 2. But you cannot find the valence number of a radical on the periodic table. So we use the table of radicals. So you have to master the valence number of radicals. So the valence number of a radical nitrate is 1. So when we interchange, because they are not equal, so we can interchange. So when we interchange, a 1 comes this side, it becomes BA1. But remember, a 2, which is more than 1, is going to a radical. So what do? Make sure that you put your radical in brackets, because the 2 is affecting both nitrogen and oxygen. So the 2 comes there. So the final answer becomes BA. And remember not to leave space between when you're writing the full formula. NO3, then 2. So there is no need for us to start multiplying 2 times N, 2 times 3. No, it's not necessary. So this is the formula that we call barium nitrate. So it's very simple, just understand the rules and then the rest is just a walkover. So regardless of how complicated the formula can be, if you understand the rules, it's very simple. Let's look at C. Ammonium sulfate. Ammonium sulfate. So how did they come up with the ammonium sulfate? So ammonium, as usual, is NH4. Remember, capital letters NH4. Then a sulfate is SO4. Valence number for ammonium is 1. Valence number for sulfate is 2. When you interchange, so this is a 1. A 1 has got nothing to do with, when you multiply a 1 with anything, you get that anything. But a 2, definitely, you have to put this in brackets. So a 2 is affecting both nitrogen and hydrogen. So NH4, then we put a 2 outside. If you want, you can do SO4, then 1. Then what is the meaning of the 1? Anything multiplied by a 1 means anything. So there is no need to put the SO4 in brackets. So this is NH4, 2, then SO4. So this is what we call ammonium sulfate. This is what we call ammonium sulfate. So there are so many examples of these formulas aluminium carbonate. So if you look at aluminium carbonate, just try to follow through this example. So aluminium, that is the symbol, carbonate, that is the symbol. Valence number for aluminium is 3. Valence number for a carbonate is 2. Once we interchange, so you notice that when you interchange, this is a 3, this is CO3, and the valence number is 2. So this number is going to an element. So there's no need to put aluminium in brackets. So it's just going to be aluminium 2. Then a 3 is going to a radical when you interchange. So definitely a radical should be in brackets. Then you have CO3, then 3. So that is called aluminium carbonate. That is called aluminium carbonate. So that is how we write the chemical formulas involving radicals. The chemical formulas involving radicals. They can give you all sorts of questions on these, but what is important is to follow the steps that we have talked about and a few regulations or a few rules that should be observed. So if it's a radical and a number which is more than 1 is a subscript, then the radical should be put in brackets. So the rest is just a matter of practicing based on the different questions that you can be given. So allow me just to give you a few questions that you can try on as you finish watching this. So write the chemical formula each following. So number 1, the ammonium phosphate. Number 2, calcium hydroxide. Number 3, the potassium carbonate. 4, magnesium nitrate. So all those are formulas that we can write. So you can try out those formulas following the rules, or maybe you can just put the answers that we expect so that you can confirm your answers. So for the first one, you need to get brackets NH4 bracket 3 PO4. The second one supposed to get CaOH OH2. Then the third one supposed to get K2CO3. Then the last one should be Mg, so that is magnesium. So it's not a nitrate but a nitrite. So a nitrite is NO2. So this is how we write chemical formulas involving radicals. For any questions, as usual, feel free to put them in the comment section down below so that we can discuss. So we have come to the end of the episode on writing of chemical formulas. Until next time, bye bye.